ఇక్కడ కొన్ని ప్రాబ్లమ్స్ చేద్దాం మనం. ప్రథమ క్రమాంక చర్యకు రేట్ స్థిరాంకం k ఈక్వల్ టు 5.5 into 10⁻⁴ సెకండ్. చర్య అర్ధాయు కాలాన్ని నిర్ణయించండి. రేట్ కాన్స్టెంట్ ఆఫ్ ఏ రియాక్షన్ ఈస్ k equal to 5.5 into 10⁻⁴. Calculate the half-life period of a reaction. Right? So in this reaction, k is given 5.5 into 10⁻⁴. Right? You have to calculate the T half. T half equal to how much? There's a relation between T half and K. That is T half equal to 0.693 by K. So that equal to 0.693 by 5.5 into 10⁻⁴. Right? So 0.693 by 5.5 into 10⁻⁴. This is in terms of the seconds. If you simplify this, you get the answer that into 10⁻⁴ seconds. So ఈ విధంగా మనం చేయొచ్చు. సో T half equal 0.693 by K. K రేట్ స్థిరాంకం ఇచ్చాడు కాబట్టి 0.693 by K 5.5 10⁻⁴ సబ్స్టిట్యూట్ చేసినప్పుడు సో 0.693 by 5.5 10. దీన్ని సింప్లిఫై చేస్తే మీకు వాల్యూ వస్తుంది. అది ఇంటూ 10⁻⁴ into 10⁻⁴ seconds. Right? So that is the answer. ఈ ప్రాబ్లంలో 200 సెకండ్ ఇన్వర్స్ రేట్ స్థిరాంకం గల ప్రథమ క్రమాంక చర్య అర్ధాయు కాలాన్ని లెక్క పెట్టండి. రైట్? ది 200 రేట్ కాన్స్టెంట్ ఇన్ ద ఫస్ట్ ఆర్డర్ రియాక్షన్, క్యాలిక్యులేట్ ద టీ ఆఫ్. ఇది సిమిలర్ దానిలాగానే. రైట్? సో కే వాల్యూ ఇచ్చింది ఇక్కడ. కే ఈక్వల్ టు 200 seconds సెకండ్ ఇన్వర్స్. రైట్? సో టీ హాఫ్ equal to how much? Similar to the earlier problem, T half equal to 0.693 by K. So that equal to 0.693 by 200. Right? These two zeros you can take to the numerator, 10⁻⁻² into, we divide this 0.2 3s are 6, 2 4s are 8, 2 4 6. Right? Right? So this is T half given second inverse, so you'll get the value in seconds. Right? So this way the problems can be done. Any problem can be done. Right? Much problems are available in the back side of the textbook. You can do it. Right? Next, we'll go to the another topic, that is the molecular collision theory. Molecular collision theory. Molecular collision theory. అనుతాడన సిద్ధాంతము అని అంటారు తెలుగులో. అనుతాడన సిద్ధాంతం అంటారు. Right? So according to this theory, today we will take up the molecular collision theory. అనుతాడన సిద్ధాంతం. అనుతాడన సిద్ధాంతం తెలుగులో. A molecular collision theory, the reactions will take place only when all the reactant molecules collide with each other. For a reaction to occur, all the reactant molecules must collide with each other. That is a very important thing. The second thing is that all the collisions may not lead to the formation of the product. For a reaction to occur, all the reactant molecule must collide with each other. But all the collisions do not lead to the formation of the product. Only such collisions which lead to the formation of product are called the effective collision. The reactant molecules must possess some amount of energy, certain minimum amount of energy, so that their collision lead to the formation of the product. Such collisions we call them as effective collisions or fruitful collisions. Right? So the molecules must possess the the a certain minimum amount of energy. That we call as a threshold energy, right? Threshold energy, if they want, there are molecules which possess the certain minimum energy, not the threshold energy. So that energy possessed by the molecule, we call it as normal energy of the molecule, right? They require much amount of energy so that they reach the threshold energy. If they reach threshold energy, they collide with each another, then the products will be formed. So the threshold energy is equal to energy of the activated molecules and energy of the normal molecules. Then, for example, here we'll take an example. Suppose potential energy and coordinate. Let us take a reaction that is taking place between reactants and the products, right? Energy of the reactants is this, and the energy of the product is this, right? This is ET, that is threshold energy. The reactant molecules, they possess certain amount of energy, this energy. But if they want to catch up this energy, they require the extra energy. This energy we call it as activation energy. So reactant molecule, they possess certain amount of energy. If they possess the remaining the activation energy, they reach the threshold energy, right? If they get threshold energy, they change into the products, right? So threshold energy equal to energy of activation plus energy of molecule. If you want the energy of activation, extra amount of energy of activation if you want, then this threshold energy minus energy of molecule. Right? Here one example what we can take is that suppose total energy is 100. Suppose the molecules, if they want to change into product, reactant molecule, they want to change into product, then let us say 100 kilocalories of energy is required, right? Total energy is 100 kilocalories of energy, right? But out of 100, the reactant molecule already they have the 20 kilocalories of energy, right? So extra how much amount of energy they require? They require 80 kilocalories of energy. So that 80 plus 20, 100 they will get it, they change into the products, right? So energy possessed by the molecule is 20, energy of activation is the 80, total 100, threshold energy they have reached, and they once they get the 100 kilocalories of energy, they reach the threshold energy, they change into the product, right? So when the molecule possess the threshold energy, they are said to be activated molecules, right? Normal molecules, they have normal energy, right? If they gain the threshold energy, right, they are, they are said to be very activated. The collision between these activated molecules lead to the formation of the product. For example, if you take the molecules A and A, these are normal molecules. They have some energy, right? During the collision of these molecules, some of the molecule they change into activated molecule. A star means they change into activated molecule. By the number of reactions, the molecule possess this activated state, right? The collision between these activated molecules that lead to the formation of product. So A star plus A star, they change into the product, right? According to collision theory, this is the phenomenon. The molecules must collide with each other. for a reaction to occur. But if the molecule possesses the minimum amount of energy, then only they change into the products. That minimum energy we call as a threshold energy. But normal molecules, they do not possess the threshold energy normally. During the collision, they get the extra amount of energy. So the extra amount of energy they require is the threshold energy minus energy of the normal molecules. So once they get the threshold energy, during the collision, they change into the products. Right? So according to collision theory, the A star and A star must collide, and that is activated molecule, they change into products. The collision, so the rate of the reaction can be expressed by equation, that is rate equal to Z into e power minus EA by RT. Where is the Z is the collision frequency, and EA is the activation energy or the gas constant, T is the temperature. Right? So according to this, the rate of the reaction is given like this. Right? Not only the collisions between the molecules should take place, but also the another factor is the orientation. Orientation must be there among the molecules. If they have the proper orientation, right, with sufficient activation energy, right, they change into the products. Not only the collision, right, with the sufficient energy, but also proper orientation must be there. That, for example, bromomethane on treatment with the alcohol gives the methyl alcohol. Right? That reaction, if we take it, bromomethane, when you treat with the OH, KOH or NaOH, right? There are two types of things takes place. One is improper orientation. Improper orientation. The other one is proper orientation. Proper orientation. Improper orientation leads to the same molecule. You don't get any product. There is no reaction at all. Same product you will get. When they have the proper orientation, then the OH will attach itself to the carbon on the back side. Slowly, departition of this bromide takes place. You will get a new product, OH plus Br minus. So improper orientation gives the same molecule. Proper orientation will give you a different molecule. That is, a product is obtained. Right? So this way, apart from the energy factor, that we require the orientation. These two will lead to the formation of the product. This is according to the molecular collision theory. అణుతాడన సిద్ధాంతం ప్రకారం ఇది. అణుతాడనాలు జరగాలి. ఆ తాడనాలు జరిగినప్పుడు వాటికి సఫిషియెంట్ ఎనర్జీ రావాలి. ఎనర్జీ వచ్చినప్పుడు అవి ప్రోడక్ట్గా చేంజ్ అవుతాయి. అలాగే ఓరియంటేషన్ కూడా ఉండాలి. ఈ రెండు ఉన్నప్పుడు ది ప్రోడక్ట్ ఏర్పడుతుంది. ఇది మాలిక్యులర్ కొలిజన్ థియరీ, అణుతాడన సిద్ధాంతం ప్రకారం.